Hi everyone. In this video, I am going to explain about the PLA example with the PLA table. So PLA we know already, we have seen in the last video. So PLA stands for programmable logic array. Programmable logic array. So programmable logic array means programmable logic. Both are programmable. Both AND gates and OR gates are programmable and are both programmable. Okay, so you should not confuse at this point of time. So programmable logic means both AND logic and as well as OR logic are programmable. Now we have to know few points regarding the PLA table. So PLA table consists of product terms, inputs, outputs as three columns. Okay, before going into that, if the size of the PLA is specified by the number of inputs and number of product terms and number of outputs, what the PLA size specifies? PLA, if the size of PLA, if the size of PLA is specified by the number of inputs, and number of product terms and the number of outputs, for then for n inputs, let us consider there are n inputs and k product terms and m outputs. Then the internal logic of the PLA consists of n buffer inverters. Then the internal buffer PLA consists of n inverter gates. Why n inverter gates? Because n inputs are there and n complemented inputs are there. So A, B, C, three inputs are there. Let us consider three inputs A, B, C. A, B, C has to generate A bar, B bar, C bar also. So to get n and n complemented inputs and n true inputs. So that's why n inverters gates are also needed. K and gates. So n inverters, K product terms will be generated by K and gates, and M or gates because M outputs are there. Each output will be an output of OR gate. Each output is coming from the OR gate. So M OR gates are there, and also M XOR gates to get true form and as well as complemented form. Okay, so this is what the actual size of the PLA. Now in PLA we know, in PLA we generate both true form and as well as complemented form. Both true form and complemented form. True form and complement form. Okay, if any function f is there, f of true and f of complement will be generated by taking the help of XOR gates that we have discussed. So both the true and complement form of each function should be simplified to see which one can be expressed with a fewer products. Suppose for example F1 is equal to AB plus AC plus BC is there. F2 is equal to something, okay, F1 complement will also come as well. And F2 is equal to something like ABC plus AC, something ABC. Okay, then which one will give you the maximum number of product terms coverage, that we have to consider. So ABC is covered here, AC is covered here, BC is covered here, which are AC and BC covered also here. Okay, so total number of product terms actually it consists of totally 6. Okay, out of 6, maximum number of product terms are covered in these underlined ones. So that's why total 5 product terms we have to consider. Okay, these we can discard. Okay, when you are going for the PLA table, so in product terms list you can consider only these 5. That is the main important issue when you are going with the PLA table, that you have to consider very carefully. Okay, so both true form and complement form, true and complement form of each function should be simplified to see which one can be expressed, which one can be expressed with a fewer product terms, with a fewer product terms, and which one provides, and which one provides product terms that are common in other functions. Product terms that are common in other functions, as we discussed here. Okay, now let us see a problem, example problem. Implement the Boolean functions with PLA. Implement Boolean functions with PLA. So F1 of ABC, 3 inputs are there. F1 of ABC is equal to summation of M of 0, 1, 2, 4. And F2 of ABC is equal to summation of M of 0, 5, 6 and 7. Okay, so now first you need to get the expressions of F1 and F2. Okay, first step is writing the expressions of F1 and F2. That is the first step. Writing F1 alone is not sufficient. F1 in true form and F1 in complemented form also you have to consider. Okay, and similarly F2 in true form, F2 in complement form you have to identify. So how to identify the expressions? By taking the K-map. So K-map for F1 true, K-map for F1 true. So yes, there are 3 inputs, 3 variable K-map we have to consider. So it is ABC 0 0 0 1 1 1 1 0 0 1. So 0 1 2 4 0 1 2 4. Okay, so you can map these two, and you can map these two, and similarly you can map this one with this one. So F1 true form is equal to A bar B bar plus B bar C bar plus A bar C bar. Three product terms are there. Now K map for F1 complement form. Okay, we know in PLA both true form and complement form we can identify. So F1 complement form. F1 complement form we can also derive from the K map, or else we can do one more thing. Just taking the complement of this one will give you F1 complement. So complement if you take, you need to apply some Boolean algebra equations like De Morgan's law, commutative law. So such laws you need to apply and derive. That is one way. Otherwise, you can have also the help of, you can take the help of K-map and simplify it. So when you are going for the complement, the mapping should be with zeros, not with ones. Okay. So A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, 1. So here whichever is left vacant, that we have to consider. This is 0, 0, 0, 0. See here. Okay, whichever is not there. Ones are not there means zeros are there. We map these two, map these two, map these two. So F1 complement form is equal to F1 complement form. Nothing but you can write it as F1 bar. You can write it as F1 bar. That is equal to AB plus AC plus BC. Don't use POS form. Okay, once again I am saying don't use POS form. As we are mapping zeros, it will be like POS form. No, because we are already mentioned that it is a complement form. So F1 is equal to, we can write simply F1, otherwise you can keep a bar here. Okay, and similarly K map for F2 true form. K map for F2 true form. A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, sorry, 0, 1. Now, here we have this one, these two, and this one. So, we can map these two, this one, and this one. So, F2 true form is equal to A bar, B bar, C bar plus AB plus AC. And similarly, K map for F2 complement form. A, B, C, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1. So whichever are not there, fill them with zeros. Map same opposite. So F2 complement is equal to A, B bar, C bar plus A bar B plus A bar C whole bar. Okay. Now we need to draw the PLA table. Okay, one thing we should consider in PLA table, that we have to identify which are the product terms that are occupying most of the other product terms. That means the product terms which should be considered must be covered in all the functions, all the functions with all the input variables, that we have to consider. Okay, no need to take a C. F1 is having 6, F2 is having 6, all 6 product terms we no need to consider. Whichever is highly covered, that we should consider. Okay, so first column is product term and second column inputs, third column outputs. So inputs A, B, C, outputs are here F1. See, F1 complement form we are taking. F1 complement form gives you AB plus AC plus BC under root. So all these terms are covered here. And coming to F2 true form, F2 true form also all the product terms covered. Okay, F1 complement form, F2 true form. The product terms are AB, AC, BC. See, AB, AC. AB, AC which are covered already in this particular F1 complement form. See clearly, AB, AC already covered in this particular F1 complement form. If you go with F1 true form is having complements of individual items which are not as a part of F2. Okay, nowhere they are mixing. Suppose if you go with the F1 true form is having all the individual complement forms which are not there in anywhere in F2 true form or F2 complement form. That's why if you take F1 complement form, in F1 complement form you have AB, AC, BC. So of course AB, AC are covered in F2 true form. See, AB, AC are covered here. So you no need to worry about these two. So simply discard these two, and whichever is not covered in that F1 complement form, that you are taking additionally. A bar, B bar, C bar. So totally 4 product terms we need to concentrate, and remaining all are discarded. That's why we have taken F1 complement form, F2 true form. Hope you understand how we have identified this. So AB means which are present, that we are taking 1, 1 and it is dash, 1 dash 1 dash 1 1 and 0 0 0. All these are complements. And whether this product term is covered in F1 or not, F1 complement form or not, yes. F2 is covered or not, yes. And here also AC is covered in both, and BC is covered in F1 but it is not covered in F2, and it is not covered here, it is covered here. Okay, so PLA logic diagram. PLA diagram. So A in true form and as well as complement form. B in true form as well as complement form. And similarly C in true form. That's why n inputs have n buffer inverters. See, total n means 3. 3 will give you 3 more buffer inputs. Okay, and how many AND gates we are taking here? According to PLA table we have to draw total 4 AND gates are sufficient. PLA table is the ultimate one. According to that we are going to draw the PLA logic diagram. Okay, and this is connected here, this is, as both are programmable, this is XOR gate to give you a true form and as well as complement form. As we have considered one true form and one complement form, one XOR gate should be connected with 0 as one input, and one XOR gate should be connected with 1 as other input. So for true form we are taking 0, and for complement form we are taking, see, F1 is complement form, so this is F1 and this is 0 for F2 because F2 is true form. Okay, so what is F2 here? F2, this one, and this one, here, 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 and here. So this is AB, Here the product term is AB, AB and AC, AC, BC, BC and A bar, B bar, C bar. A bar, B bar, C bar. Okay. So F1 complement, sorry, it is not there. Okay, see here. F1 complement expression is, see, F1 complement expression is AB, AC, BC. Whether it is coming or not, once check. See, the product term here it is AB, AC, BC, and the product term here it is A bar, B bar, C bar. Okay, so the expression is AB, AC, BC whole bar. F1 has AB, AC, BC and it gives you the complement whether it is coming or not. Okay, we have got this. And coming to F2 expression in the true form is A bar, B bar, C bar plus AB plus AC. F2 AB, AC and A bar, B bar, C bar and it is in true form because one of the XOR gates is connected to one of the XOR gate input is connected to 0. I hope you understand why we have got only 4 minterms. 4 AND gates are sufficient instead of using multiple AND gates. Okay, thank you.